And welcome to Unique Math class. In the last video, we considered exponential equations with same basis. In today's class, we'll be looking at different bases of exponential equations, how we can solve these problems. Looking at these questions, let's solve this in this class. And the first question is 10 to the power of 3 minus x equals to 4. Now looking at this question, 4 and 10 cannot be expressed to a common base. We can apply the log to both sides to solve this problem. So applying log on both sides, we have this, that log 10 to the power of 3 minus x equals to log 4. All right, we know that this log, if we have log a to the power of x, we can write this as equals to x log a. Now, if we apply this at this point, this becomes that this can be written as 3 minus x into log 10 equals to log 4. And also, from the law of logarithm, we have that when we have log 10 base 10, it equals to that 1. That's log of common base. So this, since it is log 10, we have that this is base 10 on both sides. So that becomes that this is equals to 1. So you have that 3 minus x times 1 equals to log 4. All right, we can expand the bracket by saying 3 times 1, 3 minus x equals to log 4. And to solve for x, what do? We collect like terms. That becomes that 3 minus log 4 equals to x. This implies that x equals to 3 minus log 4. That's the solution of this problem. Second question, 3 into 2x minus 2 equals 13. To solve this question, the first thing to do is to take this negative sign to the right hand side. That becomes 3 into 2x equals to 13. This becomes plus 2. All right, we have this, that 3 into 2x equals to 13 plus 2 is 15. Next step is to divide both sides by the coefficient of 2x, which is what? 3. So we divide both sides by 3. Divide both sides by 3. That becomes that 3 into 2x equals to 15. Divide by 3. Divide by 3. 3 cancel out, and we have that 2 to the power of x equals to, this is equals to 5. At this point, we cannot solve it because this is not of the same base. So we cannot apply that indices rule. Rather, we raise both sides to log of both sides. So if we have that, that becomes that log 2x equals to log 5. And at this point, we know that if log a to the power of x could be also written as x log a. Applying that here, that becomes that log x log 2 equals to log 5. Next step is that we divide both sides by log of 2, which becomes dividing by log of 2 divided by log of 2. So we now have that this cancel out. So at this point, we have that x equals log 5 divided by log 2, which is the solution of this question. The next question is 5 to the power of x minus 1 equals to minus 2 to the power of x equals to 0. All right, to solve this, we can take this negative to the power of x to the right hand side. That becomes 5 to the power of x minus 1 equals to 2 to the power of x. All right, now to solve this question, the 5 and 2 cannot be expressed to a common base. So we can raise both sides to log by saying log 5 to the power of x minus 1 equals to log 2 to the power of x. And recalling that from, if we have log a to the power of x, this could be written as x log a. Applying this here, we have that x minus 1 into log 5 equals to x log 2. All right, Now at this point, we will expand the bracket by saying x times log 5. That gives us x log 5. And we have that minus 1 times log 5 is still the same, log 5, equals to x log 2. Now at this point, we have seen that x is here and x is here. So we can collect like terms by saying, let's collect like terms. At this point, we have that x log 5 is already here. Now when this comes to the left hand side, it becomes negative x log 2. And this, when this comes to the right hand side, becomes log 5. All right. So looking at this, we can express this by, since we have x on both terms, we can factorize this, and we have x is taken out. If we divide this by x, we'll have log 5 left. If you divide x log 2 by x, we'll have log 2 left. That's minus log 2 equals to log 5. All right. At this point, we can divide both sides by log 5 minus log 2. So that becomes x log 5 minus log 2 equals to log 5 divided by log 5 minus log 2 divided by log 5 minus log 2. So this cancel out, and the final solution is x equals to log 5 divided by log 5 minus log 2. So this is the solution to this problem.